tardes. Good afternoon, everyone. How are you? Still surviving? Sobrevivimos? Okay. So I'm Isabelle. I'm going to present this in English. Usually people understand quite well my English. But I'm from here. I'm actually not from here. I live here. Been here for 20 years. I'm French originally. So at the end of this, if you want to make questions in English, in French, or in Spanish, everything works. Okay? And we'll do direct translation. So I'm a field CTO at a company called 42 Crunch. Anybody here heard about 42 Crunch? A few? Okay, we have work to do. And we specialize in API security. This is not a product talk, don't worry. It's all about the theory and the challenges of securing APIs. What I've done is I shared that presentation already. There's a GitHub link in there. If you go to my GitHub repo and you go Codemotion, you're going to find it. And the presentation will be there, and some samples and code that I'm going to show will also be there. Okay, so you can look at this after the session. Okay, so why are we here? We're here to talk about API security problems. Now, there is something else you may have heard about. It's called APIsecurity.io. It's a newsletter which actually is curated by us, by 42 Crunch. And you can see here, this is pretty new, April, March. This is like the last 5, 6 releases of that newsletter, and every single one of them, one by one, we have problems with APIs. Small companies, large companies, everybody has some kind of issues related to authorization, to authentication, to abuse of their APIs. So why is this actually happening, right? What's the problem? And I work with a lot of customers. That's mostly my role. I'm a field CTO, which means I work with our large customers and our large partners, right? And if we look at all the problems people have, basically it boils down to 3 problems, okay? The first one is, because we're using APIs, what we have done is we've changed the way we are writing applications today. Right? What we are doing is we create all those components, and even more if you use microservices and you're exploding your applications in tons of little parts that have to talk to each other, then what you will have to do is create APIs for all of those to talk to each other, okay? But also what we have changed is when we used to have an application where all the logic and the server-side logic will be handled by the application, and then we will use only the client side to display results like HTML, JavaScript, etc. Now we're doing things very differently. What we do is we have all this data and processes on the back end, we expose them through APIs, then we send a lot of information, rich information, to the client apps, should it be mobile application, web application, etc., and just say, go and do something with this. And there's a lot of that logic, control logic in particular, that used to be on the server side and now is on the client side. And the implication of that is, of course, if I go around and I don't use the application and I go straight in the APIs, all this control logic obviously is not there. I get directly to the raw data, right? And that poses some different challenges, so we'll talk about these. The second thing is, very much like testing a few years ago, maybe 10, 15 years ago, security is still very much a last, an afterthought, right? It's the typical image of we write the code, we make it work functionally, and then we have to release because business is kind of pressuring us to release that app. So we take the app, we just throw it away to the security guys, and we tell them, go secure this. You have 3 hours. Tomorrow we go to production, right? So that is still, we don't have enough time. We are not allocated enough time for security to be done properly. Right? So that is something I see absolutely everywhere. So we need to worry about security much earlier in the life cycle of our APIs. And last, and this is kind of connecting to my earliest point as well, is we tend to just run too fast at writing APIs without, thinking about the design decisions that we have to make, right? And we have to take the time to think about design in terms of, what is it that the API is going to do? What type of data is it going to access? Who is going to access this? Is it sensitive information? Is it sensitive operations? So all of that you need to know when you create your APIs to be able to take the right decisions. It could be, how am I going to authenticate users? That's one design decision, right? So if you discover very, very late in the life cycle of the API you took a wrong decision from a design point of view, changing that is going to be very, very complicated. It may even be impossible because you're too late in the life cycle. So we have to just pause and think a bit when we create something, rather than just pointing to a database and say, generate REST API, right? We have to think about this a bit, right? Now, there's tons of problems, right? So much that now 4 years ago, a new OWASP top 10 list came up. You guys all heard about OWASP, at least the OWASP top 10, pretty much everyone, okay? So there is a specific one for APIs, which is right now being refreshed. So there's a 2023 edition, which is being released in a few probably weeks. So right now it's a RC, a release candidate, right? And it has a number of issues. And we are going to focus here on the first 6, pretty much, like the top ones. So everything around authentication and authorization, pretty much the control of data and abuse of resources. So basically, how can I DOS your APIs, like that's number 4 on that list here, right? So we're going to get in each of those in a bit more detail, the first 6, which are, because of their ranking, the most prominent ones when we deal with APIs. Now, the title of this session is Building Rugged APIs, right? So what is a rugged API? It's something which is strong and resistant, but simple. Okay, so that's really the idea here, is like how can we, as we code, create much more secure APIs, right, without overcomplicating things too much, okay? Now, if there is one thing I want you to remember from this session, is this phrase, okay? There's one thing you are going to remember, is this one. We have tons of issues in APIs because for the past 20 years, we've been told when you receive some data, the first thing you have to do is to make sure that this is actually the data you're expecting, whatever that data is, okay? If everyone was doing this, we would have probably 80% less of problems around APIs, right? So that's really, really critical. And when I'm saying, so I didn't used to work in security. I worked in integration. I got dragged into the security world by my co-founders of 42 Crunch. And since then, I've become paranoid, watching some of our guys who are native hackers doing crazy things. And so it's really important, the key thing of that phrase, to relate to our friends from the UK who've had a crazy week as well, is just, stay paranoid and trust nothing. What does that mean? It's very simple. The idea simply is whatever piece of information is coming your way, the request, the headers, an IP address, like are we going to trust all the traffic that comes from any IP address? Or do we trust that the IP address that we're being shown is actually the real one? You have to really start doubting everything, right? So this is like the main principle. And you will see that as we go through authorization, authentication, and all that stuff, it applies through the entire flow, okay? So let's start with authorization. So there's 2 main things to understand from the top 10 on authorization, right? You will hear about something called BOLA, and you will hear about something called BFLA. I'm going to explain that now. One is about authorization at an operation level, right? And the other one is about authorization at the resource level. So let's start with the function level, the operation level. So that's the BFLA. So this is about what? It's about making sure that whoever is calling an operation, a function, has actually the right to do so, right? Is authorized to do so. So you know who that machine or that user is, and indeed, if they're calling this operation and we're responding to them, it's because we have formally, authorize them to actually do so. So let me give you an example of people who haven't done that. All right? So this is a breach that happened, well, with breach, we don't know really. This is something I got discovered about a year and a half ago, all right, during the Israeli elections. Some researchers found that in the actual voting app that users, citizens of Israel were actually using, there was this hidden endpoint that was an admin endpoint, right? And that admin endpoint had no authentication, and it was hard-coded in the code, right? So if you think things are hidden in the code, they're not. It is extremely simple for someone to reverse engineer like an APK, an Android application, for example. It is very easy for anyone to use developer tools in any browser, right? So none of this is actually being hidden. So they decompile the code, find out that endpoint, no authentication whatsoever. When they call this endpoint, they get all the information from any Israeli person, right, who ever used that app, right? So that's really, it's actually a double problem. And this is something I didn't say earlier on that OWASP top 10, which is going to be proven across the different examples I'm going to take, which is whenever there is a big breach, like when we talk, the typical Equifax or the T-Mobile stuff, etc. Whenever somebody is stealing thousands and millions of records, it's never because there is one problem, it's usually because you have 2 or 3 of those problems. So for example, you don't have authentication multiplied by the fact that there is no logging and monitoring of the system, so nobody detects it, and there is no rate limiting, so a hacker can just create a little loop and retrieve whatever they want, okay? So it's usually a mix of things. So here, there is a problem, of course, that there is no authentication, and therefore, and also that we have left that endpoint, which is an admin endpoint, hard-coded into the system. So problem here, obviously, there is no validation on the back end that the user calling this is obviously an administrator, okay? That's the first problem. The second one, which is API 1. So this is like the top of the list. This is like happening every 2 or 3 weeks. It's in the news in API Security.io. That one is about control of the access of a resource, right? So what that means is I'm calling an operation, right? And let's say this operation is accessing an account called with ID 123, okay? So this is mine, I'm Isabelle, I've authenticated, and this is my account, 123, fantastic. Now, Joe comes in, right, and tries to authenticate, and then tries to access account 123. It's not theirs, so they are not allowed to actually access that. So they should be rejected. That's what BOLA is about, right? It's about making sure that that resource is actually protected. So this is an example on the one. This is actually, so underneath the smart scale here, you have a link. Whenever there is a public breach, all of these are public, obviously, otherwise I will never talk about them and give their names. You have nice report of what actually happened and what the hackers or researchers have been doing to actually crack the API here, right? And here, this one is actually pretty bad. It's the typical example of there's actually, let's say, the ability to circumvent a limit. So on the client, you cannot basically declare a family with more than 16 members, right? You go behind the back and you go straight to the API. You can have a family with 1,000 members if you want, because that limit of 16 is enforced on the client side and not on the server side. Problem number one. Problem number two, once you know basically the ID of a family, right, you can go and iterate over all the members of that family and retrieve absolutely every single piece of information about them, right? And what makes it worse, and that's what makes BOLA really worse, is that ID is a sequential ID, right? So it's 1, 2, 3, and then you say, what about if I put 1, 2, 4, right? Well, that was very easy. There was a pattern there that the researchers found. So then they write a little engine and go blim, 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 right? Until they retrieve thousands of information. And this is a healthcare also application, so there's a lot of sensitive data in there, okay? So let me show that to you now in real life in a sample app, which is the one I will share after that, okay? So I'll just go here to Postman. Here we go. All right, so this is a simple app. And you guys all, oh. Okay. We see. All right, this is a simple app, as I said. Let me just close this guy who was beeping as well. All right, so, well, that's going to be easy. So I don't see my screen anymore. All right, so simple app that allows you to register some users, okay? So what I'm going to do here is just register a new user. Put this here, okay? And just say, send. All right, so when I create a new user, what do I get? I get a new user with access. I get a token, which all of you will have recognized because you're professionals as a JSON Web Token, right? And then an ID, all right? Cool. So that's my ID, this is my user. Now, what we're going to do is try to create a picture, okay? So I'm going to upload a picture based on that user. So that should work as well. We'll have to fix this, otherwise that's not going to work. Okay, so I get now a new picture. Okay, so now this is the ID of my picture, all right? Okay, now, BOLA in action would be, I register with another user, let's say this one. All right, so that picture now is not mine. It's been created by the previous user, right? However, if I take this ID here, right, and I go here and I say delete picture, it's going to work. Okay? Why is that? What did I do wrong in my code? Any ideas? So you have to do it in yours, yeah? I didn't check the token. Actually, I do, because I authenticate that user. So I didn't check that this user, which is authenticated, is the owner of that picture, right? I'm just blindly taking the ID, and I'm just executing this. Now, why is this issue so prevalent? Because that's really the key problem here, is why do we have this, right? Why is that a problem? It is a problem because it's actually not easy to fix. If you need to fix the fact that for every single piece of call, every call that you make, you have to go and validate that a user is actually the owner of some data it's trying to access, and you don't have a proper authorization fine-grained framework to actually do that, adding that after the fact in your code is actually very complicated. Right? And if you want to do that, you will have to do it probably in an external engine that will take the ID of the user, take the ID of the resource, and say yes, no. Right? So the real fix is actually to do that, to do a proper authorization. Now, what makes this problem much, much worse, right? What makes it worse is, if you don't have any, you have sequential IDs. Like, that's not what I had in here. I have a UID. Those are hard to guess, right? So abusing this API will be more difficult if the ID of my picture was 123, right? Obviously. So sequential IDs, a problem. Rate limiting. So if I have rate limiting in place, obviously behind the scenes, I cannot do a little engine that goes and retrieves thousands of records. So those will allow you to mitigate the effect of a problem, but they will not allow you to fix it, right? So you have to be careful about those. Okay, so that's authorization. Now, let's jump into authentication. Authentication, well, I have to be authenticated. Before I can actually do anything with an API, we should know who is actually calling us, right? I'm going to here state that I know very, very few examples of APIs or calls to APIs that do not require authentication. There's very little use cases where you don't want to put anything at all, because it doesn't give you any traceability of what's going on in your system here. But let me give you a nice example. So this is a brewery in the UK. Same thing. Researchers take the app, decompile it, blah, 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 right? And then they discover that every single call to every API is made with the exact same token. Doesn't matter if you log in, we don't need that token. We'll just use the one which is already inside the app, right? So they've hard-coded a long-lived token in there. So that's why somebody did that funny joke, like a beer token instead of a bear token. But every single call is the same, right? So what problems that give them? So the researchers found that this had been like this for probably, so they went back in time, took all the history of all the apps, decompiled them, and so for the last 18 months, the problem was the same. The problem is because every single call to that APIs come with the same token, the poor people on IT at BrewDog have absolutely no idea if this was abused or not, because for them, it all appears to a single identity, right? The same token for everything. Like, was this abused? Well, I don't know, right? Now, what we know was abused is that this API is actually used to obtain not tokens, well, let's say a coupon, right? To get free beers. So what they did see was an increase in number of coupons that were created with free beers. That they saw, right? Maybe that's why. All right. So it's really something you don't want to do, right? Hard coding a token in the app is really a bad idea. Now, how do we choose? This is something that I've seen with many customers, right? How do we choose the authentication that we want? Right? What is the right balance between some system, some authentications which are maybe more complex versus something which is easier for the consumer of the API, right? And really, like anything in security, it's all about risk, right? What is the risk of using this API? What is the risk of this API to be abused, right? And that's why, in general, for apps and for APIs, we really should do a threat model of back to my design time and thinking. That thinking time should be used to do a design of and knowing and understanding the risk of exposing that API, right? Now, as a reminder, right? When you have a token or you have an API key, it's by no means a proof of who is actually calling you. Why is that? Usually the example which is given there is a hotel key, right? If you register in a hotel, you have to present your passport, a credit card, your reservation. They will see if it's you, etc., and they'll give you keys, okay? Now, if you take those keys and you give them to another person, they will still be able to enter the room, right? So it's no proof that I'm the bearer of the key, as no proof whatsoever that I was actually the person who authenticated and obtained that token, okay? Now, which options do we have? From the most simplest one to maybe the hardest one from a consumer point of view. There are still people using basic authentication. Well, I wouldn't recommend that for new APIs, but sometimes people are stuck in the past because their consumers cannot do anything else. And well, that's the way it is. Remember that this is not encrypted, it's encoded, so it's base 64 encoding. So this isn't clear, really, right? So if I get that token, I have a user and a password. API keys, probably the most used one. Key of characters, this is easy to use, it's easy to generate, it's a very good user experience. I click on the button, I get a key, boom, next 2 minutes I can use my API. That's pretty cool. If I want to do something more advanced, probably I want to go and jump to something like OAuth to obtain a token, which also has the advantage of having a shorter time life. The main problem for me for API keys is they're there forever. They have no expiration time unless somebody revokes them, right? Which means that end up in code, do you know what is the #1 API key repository in the world? GitHub. 300,000 was the last count. Right, that's why you have all those secret scanning and all those cool stuff, because it's a very, very easy mistake to make, right? It's very easy to do. So at least, the advantage of a token is it's valid for 5 minutes, for 10 minutes, for 30 minutes. So if somebody is stealing it, well, they have a limited window of time to abuse the system using that token, right? OpenID Connect, this is going to give us true authentication that I was talking about because of the way it works. I have an entire day of teaching just on that slide, so I cannot go into too many details. But if you want really true authentication, session management, etc., through an OAuth type environment, this is OpenID Connect is really a way of doing it. And really, this is something which is emerging. I see more and more people using that, which is to sign requests, right? What this will give you is two things. A, you don't have keys moving around. Like what we do is, as a consumer, I have to digitally sign a request. I have to happen that signature somewhere in a header or in the body. And for the receiver call, they know, who that user is. They can validate the signature, and then it also gives you the guarantee that that content that was sent actually didn't change on the way, right? So this is something which is used on banking for anything related to payments, for example, because I want to make sure that nobody in the flow has changed the account or the money that is being transferred between accounts, for example, right? Now, another thing to keep in mind, I know, because of my new life in the security world, I knew a few hackers now, and every one of them is saying the same thing. The first thing they're going to come after is about everything related to authentication. So all your login, password reset, all that stuff, this is really the bread and butter, because if they can hack that and they can generate tokens on demand, and it's really game over. Right, so protecting those endpoints is actually very, very critical. And I see a lot of people focusing on protecting their APIs, but not so much protecting the endpoints which actually do the authentication themselves. Right, so you have to keep in mind this is really important. Okay, I'm going to skip on the demo mode so I don't have to turn around like crazy. And also because time is flying. All right, so authentication, we have to authenticate. We have to choose the right way of authenticate, right? Authorization, we have to validate, once authenticated, who is calling us and what they are trying to do. Okay, so that's kind of all at the operation level. Now, there is another level of authorization here, which is related to data, okay? And what this is all about is controlling the data that comes in and the data that comes out, right? So this used to, if you knew the previous OWASP top 10, there was this thing that was called mass assignment, another one that was data leakage, which I thought was clear, frankly, but it's all about making sure that the data you accept inbound is controlled and the data that you return is also controlled, okay? So, example, there was this problem a few years ago. There is this company in Australia who is selling a watch for kids, right? So you have kids that have this like little smartwatch with the GPS inside, so you can get in touch with them, you can talk to them, you can know where they are, okay? So a hacker actually buys one of those watches for one of their kids, and he starts poking around, like any good hacker does, in the applications and how that works, and and he realizes that by one call, just one call, right, he can update his profile through an API on that application. And by just changing one field from the value 0 to 1, it becomes the overall administrator of the entire system. Okay? It's not supposed to be able to inject that data in there, obviously, but what the API behind the scenes, so if you look at the app, obviously it's not allowing you to overload a field called admin true false, right? But if you look at the API behind the scene of the raw data, then he sees that that field is there coming out, right? So when he looks at his profile, he can see that value property, admin, whatever the name was, coming back to him on this profile. And says, well, what happens if I turn it, it was 0, let me put 1. So he became the overall administrator of the entire system, and what that really meant was he could see the positioning of every single kid that had a watch across entire Australia. So the other problem is, obviously, behind the scenes is another problem, which is like No admin ever should have that right. So there's another problem there. But so through the API, became the admin. Big problem. CEO had to, basically leave the company. It was a big scandal, right? So this is about controlling the data in, and then same thing for the data out, exposing too much information. And that comes from that architecture that I was talking about before, which is that what we do is we tend to return a lot of information back to the back through the API. Why? And we say, well, it's okay. Then the UI will just take whatever they're interested in. So I'm going to return 50 properties, and if they need 3, that's okay. This is something that happened with Uber a few years ago as well, right? A hacker found a way to retrieve the profile of the Uber drivers, right, through a mix of BOLA and authentication issues. And when they were retrieving the information about a driver, it would have the entire, up to the name of their grandmother, right? There's a huge JSON structure with 150 properties in there, with all in that, including the token that they had used to authenticate, which is really a bad idea too. You never put tokens in a response, right? So you have all this information, but in the UI, you had only 3 fields printed out of those 150. But it's true that from I would say from a development point of view, it's easier to return all the data and say, well, you guys take what you want. This is all the information about the driver, and that's it, right? But we have to control that much better. And if any of you is working on GraphQL, which is my favorite thing in the world, be very careful with that, right? Be very careful, for example, in GraphQL, if you're exposing this seriously now, there is this option that should never be in production, where if you send a query in GraphQL and you misspell a field, like you say, retrieve user account, right? The system will say, well, I don't have a user account, but I have a field called user ACCT. Is that the one you want, right? You never, this is like paradise for hackers. It's like, they don't even have to search for the name. Normally they have dictionaries, that allows them to find the right information. They don't have to do that either. They just have to make a spelling mistake, and they get the information. So make sure you return this off on any GraphQL you may have, right? So the main thing is control the data. That's really, really critical. And same happens with JSON Web Tokens. I love these are great. They're very useful, but you have to be very careful about what you put inside. In the end, a JWT is basically a structure of data. Happens to be JSON, but you can actually put whatever you want in the payload of a JWT, whatever you're interested in. And again, it is not, unless you use JWEs, which, as the name says, are encrypted, right? All of this is just encoded. So if I take the payload, if I take the header, and I just do base 64 decode, boom, it's in clear, right? So make sure, well, this is a really bad example of my fantastic application that just takes the data straight from MongoDB and boom, puts it into a JWT. That's why you have the password in clear in here, right? But you have to be very careful about that, and you have to validate those really properly and make sure you don't, transport too much data with it. So one of the patterns that you could use here is actually to the outside world, you just send a bunch of strings, right? You don't send a JWT. You send what's called here an opaque token, right? So the outside world for your users, you just want to uniquely identify them. You don't want them to rely about the content of a JOT. But when that string comes to you, you say, okay, I know who those users are, and you convert that into a JOT, right? Into a JWT that your downstream services can consume to know, I don't know, the role of the user to do authorization, for example, something along those lines. So as much as you can avoid sending back JSON Web Tokens to the outside world, just keep it within your application, okay? All right, resource abuse. So this is really about, okay, how can a user, a system, again, consume my API? What are the limits I'm going to put on this consumption? And this is particularly critical if you have, again, any authentication or authorization problems, okay? Because it's going to increment by 10x, 100x, the impact of that potential vulnerability, right? So resources, what are the recommendations for rate limiting, right? So rate limiting really is all, again, about risk, okay? So most of the rate limiting systems I know and people use are all based on IP address, right? You want to basically block people from doing X by IP address. Now, IP addresses are the easiest thing to forge and create, right? So look at that piece in blue here. This is, again, coming from a real attack problem where the typical thing, right? You do a password reset on many systems, and in order to confirm the password reset, you receive that SMS with a 6-digit, right? A lot of people use 6 digits still. Some people use 8. Now, 6 digits, it's only digits, it's only 1,000,000 point something combinations. So very easy to generate all the potential combinations with 6 digits. Very easy to do. Now, if you have so basically a hacker, what do? They have, like, say, 10 minutes to try 1,000,000 combinations until they hit the right one. If they can do that, they take over the account because they have guessed the SMS that was sent to the user. So, of course, hackers are smart, and they also have credit cards. So you go to Azure, you go to Google, you put your credit card number in there, you use Terraform with a little script that basically creates thousands of very tiny VMs, right, or containers, and each of them is trying a number of combinations, probably a few hundreds each of those. And that's it. In under 10 minutes, you've tried all the combinations, and one of them is going to come back and it's going to work, right? And it's not going to cost, I think it was like something $150 for a hacker to actually do that for the reward of taking over, right? So you have to be careful about IPs. If you're going to do rate limiting by IPs, you want to validate those IPs. What is the reputation of the ID? Is it coming from a Tor system, right? Or from bad actors, etc. There's plenty of services which allow you to actually do this. Or you can do it by token, by some fingerprinting, by something a bit more unique and more difficult to forge than just an IP address. So that's for rate limiting. So probably you want rate limiting and different rate limiting for, let's say, again, your logging, your password resets, your authentication, your authorization, etc., than for your operations. And again, probably, you probably have different rate limiting on the post to create, a resource than on the get to access that resource. So you have to, again, this needs to be designed properly. This is something you have to design, okay? What else is inside that category? So rate limiting is one aspect. The other aspect, really, this is all about denial of service, right? The other aspect is any resource behind the scenes which is being used to serve that API. That means CPU, memory, the containers, etc., emails you're sending, anything that's working behind the scenes to make your API work, right? So again, you really want to constrain that data. And this is where I'm going to introduce this notion of a positive security model. What really this is all about is making sure that you know what you're expecting. Like your limit is X, right? And anything that goes above X, we're going to block, right? So you don't want to grow, infinitely the amount of RAM that your API is taking in memory, for example. Imagine somebody has tricked you, sent you a big piece of information, you're looping over that information, and as you do so, you're starting consuming a lot of RAM, and then it's never one call. It's going to be tens of calls, and all of these are consuming all the RAM. Boom, your system is going to fall, right? Or it's going to scale like crazy, and then you're going to receive a huge bill at the end of the month, which is also a critical problem, right? You're mostly developers in this room, but this is another thing that ops really need to take care about. You want to have limits of budgets and usage. We got caught by this. I'm very honest about it. Like a few days ago, I created an API management thing for a demo and I forgot about it, right? Until my ops guy say, we have a $1,000 bill on that thing. Where is that money coming from? And it's just, I left one API, this simple API running in an API management. And then bots are like sending that stuff all the time, and that creates calls, and they count those calls. That's it, 1,000 for nothing, right? So you have to be careful about this. So if you mix bad authentication or weak authentication and bad rate limiting, this is like the boom combination that is at the root of many only the large breaches we had in the past 2 or 3 years, okay? All right, and we're gonna finish with something that you may have heard about, which is new, actually, in the 2023 list of OWASP top 10, which is SSRF, right? Server-side request forgery. And without entering into much detail, this is basically tricking your system to call an external URL, right? So it could be retrieving a malware and install it into your system. It could be go and fetch your etc password file. It's tricking basically through the API. You want to trick the API to go and fetch a resource and return that resource or save it somewhere, okay? Now, how do we protect ourselves from this? We protect ourselves from this by controlling, and it's back to my positive security model. What is it that you're going to allow to connect to, right? Probably you don't want Gopher or FTP or anything of those protocols, right? You have a number of HTTP endpoints that you want to talk to go and retrieve some information. You want to control that. So you need really to use whitelisting here, or allow lists of what it is that the system is allowed to connect to, right? And we're back to the same thing. We don't trust anything, right? So if somebody is asking us to load a resource, we first validate what is the resource that we are going to retrieve. It's all common sense in the end of validating before doing anything. Any information that comes in, you validate it before you actually use it, okay? So interestingly, you have the link here and you have the presentation. 3-4 days ago, there was a problem discovered in Azure API management based on SSRF, right? And it has exactly, and those 2 lines on blacklisting were there before I found about Azure API management, which is this. All of you guys knew this, I didn't know that, right? So what they wanted to do in the code was protecting from basically loading a file that would be on the machine where Azure API management is actually running, right? So what did they do? They blacklisted localhost and 127.0.0.1. Sounds pretty logical, okay? Except, did you know, like you do 127.0, that also works. You can connect to localhost. Or you can put it in this beautiful form here. If you try on your machine, you do a ping to 230 blah, 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 033, it's going to answer to localhost. And in their case, what they did is they registered a DNS to localhost. They created their own address called localhost.me or something like this, right? Their own domain, right? And then they tricked the system into loading from that domain, which resolves to localhost. That's also possible. Very smart hackers. Click on that link, have a look at how it's done. It's actually pretty interesting. Okay, so we're done pretty much. Now, this is a lot of information. I know it's a lot of information. There's a lot of problems out there, but it all boils down to 2 things. To validate anything that comes in and that comes out at every single level, right? And then it boils down to being proactive about this. And how do we become proactive about this? Is by doing a lot and a lot of testing, right? You're not going to scale any of this or find any of this or fix any of this in the long run if you have 1,000 APIs to take care of, unless you automate all of that. So the same way, I always tell people, today, I'm sure all of you have, your happy path covered. Happy path is like 200 OK. My API is doing what it should do when I send him the right data, right? Now, my call to action here is like for every single happy path test that you have, I would like you to write 10, and it's not that much, hacky path tests. And what the hacky path test is what happens if? What happens is instead of sending a string to my API, I send it an integer, right? What if instead of saying a username, which is an email, I send this big blob, right? This is the hacky path. And you want to automate those tests, just to make sure if you've done something wrong, you introduce a problem, next time you go through QA, CI/CD, you're going to find this problem, okay? So make sure you actually do this, automate security, and you will see that the cost of fixing those problems is going to go really, really down, okay? So thank you for your time, and you have, again, in the presentation, references as well as books to learn more about all this. I'll be here the rest of the afternoon. Unfortunately, I'm not here tomorrow, but if you ping me on LinkedIn or anything, I'll be more than happy to help. Thank you very much. I don't have much time, but do you have any questions? Or you can bring down if you have any specific. Any question? Anyone? I can't see. I'm blinded. No? As I said, puede ser en español también. Ou en français. Up to you. All right. Have a great rest of the afternoon, and I'll see you around. Thank you very much.